Welcome everyone to Data Mesh in Practice. I'm Schultze and I'm joined here today by Arif wieder, and we are going to talk about how Europe's leading online platform for fashion goes beyond the data lake. This is where I would throw a couple questions into the room to get hands up on things like who knows Zalando as a tech company. But unfortunately, due to this remote circumstances that we are in right now, I have to stick to just give you a little bit of one-sided information on the company I'm working for as well. So who's Zalando in general? Zalando was founded as a startup about 12 years ago to sell shoes online. But it started growing pretty rapidly. And by now is one of the biggest online retailers to sell fashion in general. But not only that, but even going beyond and offering these services that it has built up over the years also for other retailers, and thus really becoming a platform for fashion sales online. So the interesting part is that the company by now has more than 14,000 employees, of which more than 2,000 in tech alone. And this is really interesting because it only showcases how much of a almost big player in tech, at least in Europe, Zalando has become over the years. But this also shows what is our internal audience that we are usually working with when we are talking about data infrastructure. Who are we? I'm Max Schultze. I'm a lead data engineer at Zalando. And I've been working with the company for about 4.5 years now. I've been working on the data lake project of the company throughout all this time, starting from initial build-up of the project, but then also growing and evolving it over time into more decentral approaches. And this is exactly what we also want to showcase here today. It has been the journey that we went through and what are the things that we arrived at and that we are also currently working on moving forward. Just a little fun fact about myself, I'm all into gaming. So if you have anything that you want to discuss either about computer games, board games, card games, I'm your man. I'm usually, I like to present myself as a retired semi-professional Magic the Gathering player. So if you want to have some follow-up questions about this one, feel free to hook me up afterwards. Arif, do you want to present yourself?
Yes. Hi, I'm Arif. I'm a developer and a consultant with ThoughtWorks. And with ThoughtWorks, we, Zalando and ThoughtWorks, we've been together working on data topics for about the last 9 months. And I'm also serving as the head of AI for ThoughtWorks Germany. And I guess if there is one thing that I'm really passionate about next to software and IT, then this would certainly be coffee. So you can certainly ping me about that. And I guess I'm kind of missing a little bit the usually excellent coffee that was served at NDC Oslo in Oslo. So hopefully we can have that next year again. So before we get going, let me say a few very quick words about ThoughtWorks. So ThoughtWorks at its core is an IT consultancy. We're a bit smaller than the really big consultancies, but we are a truly global company with offices in more than 14 countries. And I guess what makes us stand out a bit is that we truly believe in the power of diversity and that we can actually make the world a better place through what we do. And another thing that we truly believe in is open knowledge. And I guess that is one of the reasons why thought workers in general are quite active in terms of writing books on IT topics, but also speaking at conferences like here, and also writing articles. And actually, one of those articles is the article How to Move Beyond a Monolithic Data Lake to a Distributed Data Mesh that was published pretty much a year ago and written by Zhamak Degani, a colleague of mine in the US. And so that article introduces the data mesh as a so to say, successor paradigm to the central data lake. And that article and the concept attracted quite some attention at Zalando at the time, and I guess this is therefore one of the reasons why we're here together today talking about that topic. And so that brings me to what you can expect from this talk today. So first, Max will tell you a little bit the story of Zalando's cloud and analytics journey and how this went over the last couple of years. Because what you need to understand is that as much as the data mesh concept didn't appear out of thin air, so to say, but instead emerged from the experiences that we made with our clients. At Zalando, there were already quite a few developments that are going into the direction of the data mesh idea. And this is probably also one of the reasons why it resonated so much with the folks at Zalando. So then afterwards, I will give you a bit of an idea about the individual concepts of the data mesh paradigm. So I will go a bit into that. And then afterwards, hand it back to Max again, who will tell you more about what we're actually doing at Zalando and what the folks, especially in the data infrastructure platform team, are doing to move Zalando closer to that idea of a distributed data mesh. So this is where you go on, Max.
Thanks, Arif, for the quick intro. So, as already mentioned, I want to take you a little bit on the journey here on how the Zalando Analytics actually started developing, where we are coming from, how the whole cloud looked like, and then what was the state that we were in when we started thinking about the whole data mesh idea. So as I already said before, when it comes to current numbers, Zalando is having around more than 2,000 people actually working in tech. And each of these is potentially a customer of the central data infrastructure. And this is quite interesting because that, of course, shows the scale that we are operating in actually. So we are really talking about like terabytes of data every day. We are talking about a total storage size of around 10 to 15 petabytes of data. We're talking about thousands of data sets. But of course, this did not right away start like this, right? Originally, the company was much smaller, but already had a very strong focus on data. Like a lot of decisions were based on data, a lot of data was collected over time, but the whole setup at the very beginning was much simpler. Originally, the whole company was running in a single data center where there was like a monolithic application for the shop. There was a lot of parts of that which were providing different services, which each had their own backend databases. And then there was one big central data warehouse where the data was collected to do reporting, analytics, and actually provide information to base decisions on. This was quite simple setup for that regard, because if you're running within the boundaries of the same data center, you can always directly, let's say, open up a JDBC connection to your backend database, fetch the data that you're actually interested in, usually in nightly ETL jobs, pump it into your data warehouse, have like huge reports being generated, a lot of data aggregation happening, and then you're good to go. This became a bit challenging when Zalando started to scale. And eventually we hit the boundaries where we needed more flexibility in terms of resources that the data center couldn't offer anymore. And even a single data warehouse was at some point just becoming too small for all the data that was actually valuable for analytics. And that's when the first step of the evolution started. And the decision was essentially made to move the company to the cloud. The interesting point here is that of course means that all the services which were usually before running together and easily accessible were now running in separate environments. At the beginning, every team actually had their own AWS account. Zalando's mostly running on AWS, I should say here. And they had separate environments where they were operating their services and where they are operating also their local data stores. And they were not so easily reachable anymore because you could usually, if at all, only talk to the public internet. So you didn't have like all these direct connections that you had before anymore. And that's when the decision also was made to build a company-wide messaging bus. I think that's a pretty common pattern that many companies actually went through. But the interesting thing here, of course, was that the first purpose of this messaging bus was to act as the communication channel between these microservices, which no longer had the chance to directly talk to each other. Of course, at that time, we also realized that this messaging bus already contains a lot of the valuable information that the company is producing. And then soon after, a second purpose was added to take this as the first big source of data for a newfound data lake in the company. A little bit fast forward, what do I actually mean when I was talking about data lake of Zalando? Usually I'm dividing this into three areas, which is ingestion, connection to the sources, data pipelines that actually bring you the data in. There's the storage layer, and then there's a serving layer on top of that, which allows you to actually access the data and do some processing with it. And to fill this with some details, what were the main ingestion pipelines that we had at that time? Well, the first one I already talked about. There was a central event bus that we had one pipeline connecting to that essentially was archiving all the data that was flowing through this event bus. So everything that was published, there was a copy archived in the central archive of the data lake. The second big source that we connected was actually the legacy data warehouse that at that time was still running in the data center. There has been like, I don't know, 8 or 10 years of logic built up in this original data warehouse. And of course, it's not that easy to just like snap a finger and move everything to the cloud. Like a lot of this logic that has been built up is very much worth preserving. And a lot of the output of the aggregated data sets, which I also have to admit some of them are even still running today, are still so valuable that it totally makes sense to have a copy of this data also available in the data lake for a broader audience on the accessing side. And then last but not least, pipeline to actually collect web tracking information about the users which are visiting the Zalando site. This information is highly valuable when you, for instance, combine it with some sales information from the other sources to identify certain patterns on the buying side or general user behavior. When I'm talking about storage, as I already mentioned, Zalando is almost exclusively running on AWS. So for that matter, it was pretty easy for us to actually define the big storage backend that we were, because we were actually looking for a simple storage solution and went AWS S3. That was like kind of cheap and still had the potential to easily scale a lot. When talking about storage, it's not just about storage of the data itself, but also of the metadata that comes with it. So even starting with simple technical metadata like size of my data sets, schema of the data that is actually published, how do different data sets connect with each other, and then even high-level descriptions of what the data is actually about, so that people can analyze this and start using the data more easily. And then on the third side, on the serving side, we essentially have a split approach for querying access of the data when you just want to crunch some numbers and produce some results and have like ad hoc access to the data. That's what we are using Presto for. A lot of the data analysts are quite familiar with the SQL interface. So Presto as a distributed SQL engine is serving us quite well to actually fulfill exactly this purpose. And the interesting part then is we have the second part where what we call the Databricks processing platform. Essentially what that is we are operating Spark as a service for other teams. And that is Spark run through Databricks, which is one of our partners, where we have a central offering of compute capacity operated by a central team, but then given to the users who then essentially can use this compute capacity to do whatever they need to do to achieve their part. This is mostly for data transformation. So this is like the big jobs which are actually processing data and doing like a bunch of things like pre-aggregations and transformation of data. And then last but not least, we also have a catalog, which is usually starting point on the discovery side for actually getting your data journey rolling. Centralization has certain challenges. And this is what we realized over the years of operating this system, where we were facing more and more issues when it really comes to looking at who's actually working with the data. So usually you have three perspectives of people who are working with data. The one are the data producers, the one who actually, well, yes, produce the data. There is the central infrastructure team, which in our case was responsible for not only archiving the data, but also giving the access. And then there were the actual users who, well, want to actually use the data. And this creates like a sort of a disconnectedness between the users and the consumers. Because in the end, the infrastructure team, they don't actually know so much about the data they are dealing with. That's why we usually call them data agnostic infrastructure teams. But when you then have a user that wants to use a certain data set and they want to learn about this data set, they would usually just reach out to the infrastructure team. But the infrastructure team doesn't really feel that and a ownership for the data sets they are dealing with, because again, we are dealing with thousands of data sets. You cannot know everything about all those data sets, right? But then again, the actual producers of the data, they also didn't really feel a certain sense of ownership because, well, they were just producing some data, sending it, let's say, to the central event bus, and then there was a central pipeline that was archiving the data, and some of the producers didn't even know that their data was archived. They didn't even know that they had users. And of course, this created lack of ownership, which was really problematic at times. At the same time, with this lack of ownership also comes a certain lack of quality, because the data infrastructure team, which is operating all these pipelines, they usually check like on a higher level if everything is working fine. Is the pipeline working fine? Is the data properly processed? But they don't actually run data quality checks for every single data set. And because there's, again, this disconnectedness between the producers of this data, where usually these issues originate from, and the actual consumers of the data, which are now facing these issues, it's really hard to actually get them together without the involvement of the infrastructure team themselves. And leads to the third big issue that we were actually facing, which is, well, the central team becomes the bottleneck. Whenever there is an issue on the user side, they don't know about who's actually the actual producer or the owner of this data, and they reach out to the central infrastructure team. And that actually leads to the position that the central infrastructure team then needs to acquire certain knowledge about the data, about the domain it's coming from, to dive deep into specific issues related to single data sets. And of course, this does not scale, right? And looking at these three issues that we were facing here over time, I will actually now hand it back to Arif to tell us a bit more about these issues and how they can be seen on a more global scale.
Great. Thanks, Max. So, having been a consultant over the years, and therefore also having been a member of several data teams over the years, I can really say that those challenges that Max just described are really very, very common. So in fact, I have seen that situation in pretty much every single data platform team that I've been with that had central data ownership. And so what Max just described is really a recurring pattern that we can see. So if we step back a little bit, we have those three parties that Max mentioned. We have the data producing teams on the left. And so those are really the product teams, right, that build products, that build reliable systems. And they are kind of okay usually with the situation, yeah, because they have their own incentives and they are, so to say, happily generating data, right? And then on the right side, you have the data consumers. And actually, sometimes those data consumers are the product teams as well, then when they want to work in a data-driven fashion. But those are often decision makers or data scientists, for instance. And they are already feeling the consequences and the implications of those ownership and data quality issues that Max mentioned, right? So they work with the data and they really then complain that something is not wrong or the data quality is not right. So they're already struggling a little bit. But then the third party, which is this kind of usually team of data engineers maintaining such a central data platform, they are really the ones who are in a quite tight spot, because they have the responsibility to provide reliable, fresh data to the data consumers. But at the same time, they're often constantly doing firefighting and dealing with issues that have been introduced because of changes coming from the data producing teams, and then trying to solve some problem where they are really not the experts on, right? They don't really know what the data means, and they try to solve a problem. And at the same time, they are the ones where the data consumers will come to, right? The data consumers will rightfully so complain and will come to the central team and ask what's wrong there. So this is really quite an unfortunate situation that those central data teams find themselves in quite often. And interestingly, that it doesn't matter whether this is a central data warehouse or a central data lake that you're building there, because the problem is the centralization itself. And to be precise, this is not necessarily about the technical centralization. This is about the central ownership. Because simply, when you imagine that you have on the left the data consumers and the number of data consumers ever growing in a thriving company, right? More and more data is being generated. And then you have on the right side, you have the number of data consumers also ever growing in a company that is thriving to be data driven. So more and more people want to do things with data. And then you have this central data platform in the middle, which will eventually become this bottleneck and really doesn't scale very well. But now, what is actually the reason for this to scale that bad? The reason is that a central data team or a central data platform that also has central ownership of data is essentially a data monolith that cuts through domains. And so to give an example here, let's imagine we have a checkout service here on the data producing side, right? And this checkout service is built by a team of developers, and they maintain this checkout service, and they have their own database, so their own data, and they also generate checkout events. And those checkout events end up in the central data platform. So now you see that this one domain about checkout knowledge, right, or about checkout data, that this is scattered across multiple teams. It's to one part, it belongs to the team or even several teams maintaining those production services about checkout activities. And another part of it is owned or it is in the realm of responsibility of that central data team. And that really means that kind of the boundary of this central data platform cuts through this domain right away. And that creates a lot of friction, misunderstandings, and ultimately prevents this model from scaling. And coming from those observations that we've seen again and again, what is the data mesh now about? So the data mesh concept really is, as I mentioned from the beginning, it's a concept that we came up with seeing good approaches happening at our most progressive clients and bringing them all together. So interestingly, the data mesh concept is really mostly about ideas or to apply ideas that we have already successfully applied to the software engineering domain over the last couple of years, but to now apply them on data challenges, which has not been the case before. And really, three key innovations here are to apply product thinking, domain-driven distributed architecture, and infrastructure as a platform to data. And I will go through them now one by one. So let's start with the first one, product thinking. And I want to start with that one because I believe that is also really the one that can help the most with those ownership issues that Max mentioned. And the idea is quite simple. So you want to treat a data set as a product. So what does that mean? That means that you need to answer product-specific questions. So for instance, what is the market for my data? But also, therefore, who are my customers, right? And what are their needs? But then also things like, how do I even make sure that my customers know about my offering, right? How do I do marketing? And ultimately, even things like, what is even my USP? So how do I distinguish my data offering from other data offerings in the company? And so to thoroughly tackle those kind of product questions about data, you usually want to have a dedicated person dealing with this, and that would be a data product manager. And so now this data product manager should be part of a cross-functional team building and maintaining such a data product as an autonomous service, basically. And that means you will have data engineers, infrastructure engineers, etc., working together to build data pipelines, for instance, but also to create documentation and generally provide all the capabilities to make this data available to their customers. So now the second key idea here is to apply domain-driven distributed architecture or domain-driven design to data. So what does that mean here? It means that such a data product must be focused on a clearly defined domain and must really look at what are the domain boundaries and what is the bounded context here. So the underlying idea here is that when you build a data product around one such a domain, then that means that the team building that data product, that they can become domain experts. And that will lead to the good situation that you can solve data problems where you need domain-specific knowledge about the data right at the place where this domain-specific knowledge is. And this is really quite an enabler when it comes to scaling data, solving data problems. And now you want such data products to become the fundamental building block of a distributed mesh of such data products, right? And that means you can have data products for domains, you can have data products for subdomains, depending on how complicated the domains are and how many people you need to deal with them. And you can have different kind of domains. So typically you have what we call source-oriented data products. That means those are domains that are very much centered about the specific knowledge of how certain data gets captured, right? So for instance, an example here would be web tracking. Depending on what you use to capture the data, there are quite some intricacies that you need to know about in order to make sure the data quality is right and to provide it in a high quality and reliable fashion. And so this specific knowledge is then captured in such a source-oriented data domain and in the respective team. But then on the other hand, you can also have so-called aggregated data domains. And so those are kind of higher order domains that usually build on top of existing source aligned data domains. So an example here could be, for instance, I don't know, maybe a recommendation, maybe recommendation data, something that really builds on other data and creates more value, but that is still interesting and complex enough that it justifies to be treated as a separate domain that has separate domain expertise. So now this idea of such a mesh of individual domain-focused data products has quite some similarity to the idea of a microservice architecture. And kind of similar to microservices, not every service is automatically a microservice, at least not in the way how we understand these terms today, right? You want a microservice to be independently deployable. You want it to have SLOs, etc., those kind of things. This is really what we understand these days, what a service has to have in order to be a proper microservice. And the same is kind of, or a similar thing is true for data products. There are certain things you want to have in place before you can call something a data product. So one of those things, for instance, would be to be discoverable. You need to be able to find the data. Then you need to be able to address the data so that you can actually work with it. And in order for this whole thing to scale, it needs to be self-describing, right? And then furthermore, of course, it needs to be secure and trustworthy. And all of this is for the ultimate goal, which is to be interoperable, because that is really kind of the key thing of this mesh to scale and to work out, is that the individual data products need to be interoperable. And this is also similar to the microservice idea, where usually you have really interoperability at the core of the success of the microservice architecture pattern. So, and that brings me to kind of the third key concept here, which is self-service data infrastructure. And generally, the main motivation here to provide a data infrastructure platform is to avoid that each of those autonomous data products, that they need to build up their own infrastructure and have kind of duplicate efforts, right? And this is from the general idea really not very new, and this is really what the public cloud providers are doing all the time. They provide self-service platforms to come up with your to provision your infrastructure. Now, what is important in this particular setup is that such a data infrastructure platform doesn't become a data platform. So it needs to stay domain agnostic. And that means basically when you're, for instance, an engineer, part of the team building such a data infrastructure platform, and you realize that you need to have some domain knowledge about one of those data products in order to solve a problem, then that is probably a sign that you're already on going in the wrong direction again, where you're on the way to building the next monolithic data platform with central data ownership. And this is really what you don't want. Instead, you want this data infrastructure platform to provide domain agnostic self-service tools and capabilities that really enable autonomous teams building data products. And so, for instance, a good indicator of how well you're providing such a data infrastructure platform is how quickly can a team create a new data product or the infrastructure for a new data product, simply using the means that the data infrastructure platform is providing without having to contact the people maintaining the data infrastructure platform, but really just using those self-service tools. And now all of this has to be governed by some global governance and global standards. But the key thing to keep in mind here is that this global governance should really only be for, or should mainly be there for enabling interoperability. So at the point where kind of you're doing too much governance at a central place, you're working against the scalability and against the autonomy of the individual teams and data products again. So you need to make sure you're only doing as much central governance as is needed to provide this interoperability for this ecosystem of data products to thrive. And now, before I will hand it back to Max, who will really tell you more specifically from that perspective of the data infrastructure platform, let me wrap up a little bit and highlight one thing. The data mesh paradigm is really more a mindset shift and not so much a technological shift. So the data mesh idea is about going from centralized data ownership to decentralized data ownership. It's about not looking at technical things like pipelines as the first class concern anymore to structure your data landscape, but instead to look at domains as the first class concern to structure your data landscape and your data structures. And it means that data is not a byproduct anymore, but really becomes the product. And this means that you want to go away from siloed data engineering teams that are building their central data platform, but instead you have cross-functional teams with data engineers in them that build those data products. And ultimately that means you go away from a centralized data lake to an ecosystem of data products. And I'm giving it back to Max here.
Thanks, Arif, for this great introduction to what we actually mean when we talk about this data mesh and the concepts behind that. And now, as Arif already said, I would like to highlight a little bit of what are the, as part of this concept that we already had the chance to put into practice. And here I'm also specifically focusing on this infrastructure perspective, because that is exactly the team that I'm representing here as well. Just to give you a quick recap once more, we were originally coming from this central infrastructure. There's always been the bottleneck that was always contacted by all the users and the producers whenever there was an issue on either side. But where we actually wanted to get was, as Arif just described, to become a data infrastructure platform team that does not need to actually dive deep into these details all the time, but that just provides infrastructure that people can then use by themselves. And at the same time, going very with the same idea, we wanted to get away from the central data platform and from this actual data monolith, we like to call it as well, towards these interoperable services. Just to show you a little bit of how we started moving in this direction, I want to essentially take off where I left off with the original problem statement and take you again back to the journey that we've been following specifically over the last couple of months and years. So what we started off are the components that already existed in our central data lake. So there was central data lake storage. There was several petabytes of data already that were stored in central places that were still very valuable to the rest of the company. And of course, we didn't want to throw that away just to spread the data, but this was very valuable information that, of course, needed to be kept around. And also on top of that, we already had like a metadata layer that was covering the whole data that was already stored there. This was, again, like about all these additional information that you keep about the data, which is not part of the data themselves, like descriptions, high level of what these data sets are about and how they can be used. But this also included a governance layer in terms of having clear descriptions about, let's say, which data sets actually contain confidential information, but also the whole access management around this. So who is actually allowed to see certain confidential information? We already had something in place that was working very well to actually follow these kind of processes. So the next step that we actually wanted to do was we wanted to add more data easier and directly provided by the teams who actually own the data. And that's why we went with a concept that internally we called bring your own bucket, or BYOB, to have a more fun description, to enable people to share the data sets that they store in their own buckets, in their own accounts with this already centrally provided infrastructure. And here we got good help from how AWS, specifically S3, is structured in the backend, because all our services are actually running in the same region, which means that S3 in the backend is not actual like physical separation of the data, but it's much rather a logical separation between these different accounts. But accessibility of this data across account boundaries is very easy if you have the proper access rights. And this enabled us to essentially allow people to do exactly that, bring their own buckets and share that with the central buckets and just put them together next to each other. And this already was the first step to foster a culture of increased ownership for the data sets. Because if I am the one who actually stores the data by myself, and I know now that this data is also used by somebody else, then I have already an increased ownership and an increased responsibility for also providing proper quality, but for also interacting with my users more often. The second big step, when we started building up on something that we already started, are these process platforms that I already mentioned. So here we are providing infrastructure to other teams without actually needing to learn about what they're doing with it. So we have this central Presto infrastructure in place where users just get an interface where they can fire SQL queries against data sets. But when they actually have some questions around the data sets, they will not talk to the infrastructure teams, but they will talk to the actual data owners. And even more so with the Spark processing platform that we are running on Databricks, here we are providing clusters for teams by just following templated definitions. So the team needs to tell us how big should the cluster be, who should get access to the cluster, which kind of data sets this cluster should get access to. But then, like, based on such templates, we just create the cluster for the team. And yes, we operate it in a central way. So not that every of these, I think around 100 teams that we already have, which is using this right now, have to all first build up a Spark cluster by themselves and maintain it themselves. This is not necessary. But once we hand over usage to the actual requesters, like the central team does not at all know anymore what they're actually doing, and they don't need to. And that's the great part here, because they can completely act independently from the platform team, while the platform team is literally just doing that, providing a platform. What we wanted to foster even more, and that was like the next step in our journey here, was that we just wanted to simplify data sharing across technologies. And here we went with an approach where, because we already had this metadata / governance layer, which more and more just became an interface for data, it was much easier to actually connect additional technologies. Like, for instance, if you want to also some data that you are storing in your RDS database, or if you want to connect your Redshift to some central S3 source just to load some data in your localized domain data warehouse. And this was the whole idea how we started like adding more parts, just because we had the chance to have this infrastructure interface, which could be easily used by all the teams who needed to get involved with it. So just to summarize a little bit on what the ideas were from the technical changes that we made here, was again exactly what Arif mentioned before. We wanted to go with central services that had global interoperability. And here the important thing to actually figure out was that decentralized ownership does not necessarily mean decentralized infrastructure. You still can have central infrastructure like we actually have here with our processing platform, which is operated by a central team without actually needing to involve them in every single business process that is built on top of that. And here we really went with differentiation between decentral storage and central infrastructure. And for that matter, also with the ownership, which was much increased already by the decentral storage, together with the central governance, because we already had these processes in place that were actually operating very well throughout the company. And after all, we also just had to realize that interoperability is created through convenient solutions of a self-service platform. This was like a little bit of a reflection on the technical things that we did. And now I also want to add some more things that change on the behavioral side and that we tried to foster in terms of behavior towards our colleagues and the different teams at Zalando. Once more, short recap, we were coming from the situation where the data sets were provided through central pipelines by this data agnostic infrastructure team. So there was no clear ownership, there was lack of quality, but we wanted to really have the possibility to give more power and also more responsibility to the producers of the data, to not just be byproduct producers, but actually be owners of actual data products. First thing that we started to actually ensure data quality was we asked the people to make conscious decisions. We came from the background of just archiving every data set from a specific data source. But a lot of the producers of these data sets, some of them didn't even know that these data sets were archived. And accidentally, then somebody also started using these data sets. And accidentally, they started building up production processes on top of that. And accidentally, there was an accident and everything broke. Instead of continuing with this particular behavior, we just wanted to actually ask the people to make conscious decisions of what are the data sets that should be archived and that should actually be made available for analytics. So we went away from this solution of default storage of everything, and we asked the people to opt in for their particular data sets, because once they actually actively opted in to store their data sets, then you at least know that there's an awareness on the producing side that there is a data set that is stored and archived, and that there is the potential that people are actually using that. Speaking of usage, this was actually the big part that we started to look into. We already had tons of data sets, as I said, thousands of data sets, petabytes of data that we were already storing in the central data lake at the beginning. So we started to have a look at the actual usage statistics for these data sets. We figured out there was a lot of data sets, actually the majority of them, which were never used at all. And this, of course, is a huge liability, not just in terms of costs. Well, you are paying for this data that you're actually storing. And trust me, S3 is a very nice and very cheap option for data storage. But when you're talking about petabytes of data, it starts adding up. Also, it becomes a liability in terms of compliance. If these data sets now contain customer information, for instance, they all of a sudden become part of GDPR processing, and you need to take care of them in additional ways as well. So these were the first things that we wanted to tackle and really figure out, separate the ones so that we can understand what are the data sets that we even potentially couldn't get rid of, both in terms of cost-saving measurements, but also in terms of increasing the compliance, because those data sets were not adding any value at all. The second class was then, of course, some data sets were used, not super frequently, but maybe a couple of processes were running on them. That's usually then a fine situation to just leave it like that. But most importantly, we also found these third class of data sets, which were usually just like a very small portion of the data sets that we had stored, which were heavily used. Like those were the golden data sets that tons of decisions were based on, that like the majority of your machine learning use cases were running on, that like, a lot of reports were generating on, and they were used for many, many downstream processes. Identifying these data sets now also gives you an option to say this data is so valuable that it actually makes sense for the company to dedicate additional resources in providing this data really as a product, but also increasing the quality, and maybe even work much more into the direction of product thinking that Arif earlier described, in terms of identifying what is my product actually about, what's my unique sales point, but also just the user happiness, just to serve the consumers of your data sets. And we were essentially asking for these behavioral changes from the data producers, because data should become this product that is not just a byproduct that is produced by accident, as I already said before. By understanding this usage of your data and by having these conscious decisions of actually providing your data and making it available to the people, we then also enabled the data producers to actually dedicate resources, not only to understand the usage, but also to ensure the quality. Because in the end, the data quality for us really became a contract between the consumers and the producers. Only if there's enough demand for actually increasing the quality, and if there's enough value that is actually generated through the data product that you are providing, then it makes sense to invest a lot of time and additional resources to dig deeper into the issues we're providing here. These were the things that we were changing in the company to foster behavioral changes, most of the times on the data producer side. But what I also want to give you on the before we are closing out this talk here is what are the things that we are currently tinkering with? What are the things that we plan to go deeper into the future? And that's exactly where I just want to give you a little bit of an overview of two of the main points that that we are actively working to prepare further data processing improvements and data infrastructure improvements for what we are having here. The first one is we are actually actively working on a domain enterprise architecture. So what does that actually mean? Well, first of all, we actually need to define for ourselves what actually is a domain. And of course, then right away, the next point comes, what are actually the responsibilities for the domains? And once you have this cleared out, you then even need to appoint domain-specific experts that become like the first point of contact when it comes to any kind of questions related to the data process, to the data products of this specific domain. And this is something that we are currently actively working on to define all these terminology inside of Zalando, and then to try to roll this out on a company scale to really have also a little bit of an organizational change to structure your data processing more and more into these domains and apply this domain-driven thinking here also on the data aspects. The second big point that I also want to mention here is off-the-shelf products. So what we want to have, and this goes again much more into this idea of the data infrastructure platform, is you don't want to have centrally operated services anymore, but you want to have tools that people can just use into the other tools that they are already using and just operate by themselves and then have the full responsibilities of the processes they are actually running. One of the things that we are currently working on is we want to decentralize the archiving of the data. Instead of having these central processing pipelines, which are consuming thousands of data sets and are archiving them, going much more with this opt-in approach that I said, to also actually enable the people to archive data sets by themselves and again, make them available through the central governance afterwards. And then we also want to work towards what I like to call template-driven data preparation, where you essentially can have certain, let's say, Spark jobs, which are already prepared to work on very common patterns. There are certain processes and operations that a lot of teams are essentially reinventing the wheel every day, like repartitioning data, like transforming data from, let's say, JSON to a binary format. And all these, there's like many, many more of these kind of jobs which are done over and over again. And for these, you want to have some things like templates where people then only need to adjust the part that is very specific to their particular use case, but all the stuff that just needs these centralized processes, they can just essentially plug and play for that regard. That was a little bit of the outlook of the things that we are currently tinkering with. And with that, I actually want to close it out. This was Data Mesh in Practice. I'm Max Schultze, and I was joined today by Arif to talk to you about how Europe's leading online platform for fashion goes beyond the data lake. Thank you for your attention, and we are open to receive any questions, either here in this chat or also via the Slack room. Thank you.
Yes, thanks a lot, everyone.